definition of infinite series. Let an be a sequence of real numbers. Then the expression summation n is 1 to infinity an is equal to a1 plus a2 plus a3 plus so on is called an infinite series. So now, first of all, what is given here? An be a sequence of real numbers. Okay. So here an is what? An is a sequence of real numbers. Here n is vary from 1 to infinity. So here put n one by one. So first element is a1, second element is a2, a3 and so on. Okay. So this is the infinite sequence. Now sequence means here this one is a ordered list and it follows some rule. Okay. So this is the sequence. Now we are adding the elements of sequence. Here a1 plus a2 plus a3 and so on. Okay. So this is written in a form of summation. Summation of n is 1 to infinity an. Okay. So for series what we need? First of all we need the sequence. And if we are adding the elements of sequence, then it become a series. Okay. And series is written in form of summation. So this is the infinite series. Now the sum of first n terms of the series is written as Sn is equal to summation of k is 1 to n ak is equal to a1 plus a2 up to so on an. So Sn is what? Sn is sum of first n term of this series. This series contain infinite number of terms, but from infinite number of terms take only first n number of terms. Okay, so that's why k is 1 to n. Now put k equal to 1, so we get a1, k equal to 2 a2 plus k equal to 3 a3 up to k is vary from 1 to n. So last element is what? an. Okay, so this is the sum of first n term of the series and it is written as Sn. Now on base of Sn, condition of convergence, divergence and oscillation of an infinite series. What is the first case? The series an is said to be convergent if limit n tends to infinity Sn is equal to s, and s is what? Some finite number. So here actually what is the concept? Here what is Sn? Sn is sum of first n term. Okay. Now on Sn apply limit n tends to infinity. So it gives the, for very large n we get the sum. Okay. Here n tends to infinity. Apply on Sn. So what we get? We get sum for very large n. Okay. So this sum is same as the sum of the entire series. So on that base we can say if this value is equal to some finite number, then our series is convergent series. The series an is said to be divergent if limit n tends to infinity Sn is equal to plus infinity or minus infinity. Okay. If this limiting value is either plus infinity or minus infinity, then the series is what? Divergent series. Third, the series an is said to be oscillatory if limit n tends to infinity Sn does not approach any single finite value. Means after evaluating this limit, what we get? We get more than one finite value. Okay. So that's why the limit fluctuates between more than one finite value. Okay. So this series is known as oscillatory series. So divergent series and oscillatory series, these two series are considered as divergent series. Okay. So this is the divergent series. If in question, the question is like that, find the convergence of the series and also find the sum okay, sum of the series. So in that case you can use the Sn. Otherwise no need to apply this test. For every kind of series you cannot find the sum of first n terms, okay. But if sum is asked, so in that case think about Sn. Necessary condition for convergence of an infinite series. If a positive term infinite series n is 1 to infinity an is convergent, then limit n tends to infinity an equal to 0. This condition is necessary but not sufficient. So what does it mean? This means if a positive term infinite series an is convergent, implies limit n tends to infinity an equal to 0. But we cannot say if limit n tends to infinity an equal to 0, then series is convergent. Okay. So what is the meaning of necessary condition? Only one way is possible. Okay. If a positive term infinite series is convergent, अगर कोई भी सीरीज कन्वर्जेंट है तो ये कंडीशन सेटिस्फाई होगी, लिमिट n टेंस टू इंफिनिटी an इक्वल टू 0. बट इफ लिमिट n टेंस टू इंफिनिटी an इक्वल टू 0 हो रहा है तो हम ये नहीं बोल सकते कि ये सीरीज कन्वर्जेंट है, ये सीरीज डाइवर्जेंट भी हो सकती है. ओके, सो दिस इज द नेसेसरी कंडीशन फॉर कन्वर्जेंस ऑफ एन इनफाइनाइट सीरीज. Geometric series. A geometric series is of the form a plus ar plus ar square plus ar raised to 3 up to ar raised to n minus 1 and so on, where a is the first term. This a is the first term and r is the common ratio. Now how to find r? So each term is divided by the previous term. Okay, here second term is divided by first term, third term is divided by second term, fourth term is divided by third term and so on. Okay, so you will get the ratio r and this ratio is common. Let's check. Second term ar is divided by a, first term, so we get r. Okay, same way third term is divided by the second term, so again what we get? Ratio r. Okay, r is a common. So here r is the common ratio. Now we are interested to find the sum of first n terms of this series. So it is denoted by Sn. Sn is equal to what? A plus ar square up to ar raised to n minus 1. So here we are considering sum of first n terms. This sum is written as a 1 minus r raised to n upon 1 minus r. But here what is the condition? This one is for r is not equal to 1. Because if r equal to 1, then denominator becomes 0 and this is not possible. Okay, so that's why this Sn is defined for r is not equal to 1. Now on that base we discuss the various cases. First case is r equal to 1. Okay, so for r equal to 1 find Sn. For this case put r equal to 1 here. Okay, so Sn is what? A plus again r is 1, so we get a, again r square means 1 square, so again we get a. Okay, so what is the Sn? Sn is equal to a plus a up to n times, because this is the sum of first n number of terms. Okay, so we get a n times. Okay, so for r equal to 1 Sn is what? Na. Now apply limit. So limit n tends to infinity Sn is equal to limit n tends to infinity Na. N is infinity into some finite number. Answer is infinity. Okay, so this series is divergent series. We discussed earlier, if limit n tends to infinity Sn is equal to either plus infinity or minus infinity, what we conclude? The given series is divergent series. Next case, if mod r is less than 1. Mod r is less than 1 means minus 1 less than r less than 1. Okay, now in that case limit n tends to infinity r raised to n equal to 0. Now see here, what is the range of r? R is lie in a range -1 to 1. So to understand this limit, let's take, suppose my r is 0.5. Can I write? Because 0.5 lie in this range, okay? So now what is the limit n tends to infinity? 0.5 raised to n. Limit n tends to infinity 0.5 raised to n. Okay, so for very large n, what we get here? For very large n, we get 0.5 raised to 1, 0.5 raised to square, 0.5 raised to 3, 0.5 raised to 4, okay? So this number become smaller and smaller, okay? And this number approach to 0. Say yes or no, okay? So in this range, limit n tends to infinity r raised to n equal to 0, okay? Now, apply Sn here. Take this Sn and apply limit n tends to infinity Sn, okay? So limit n tends to infinity Sn is equal to this value. R raised to n become what? 0 from this, okay? So this value becomes 0. We get 1 minus 0 in numerator. So a upon 1 minus r, okay? So for mod r less than 1, limit n tends to infinity Sn is equal to a upon 1 minus r. And this is what? Some finite number. Okay, so that's why what we conclude, the given series is convergent series. Okay. Now let's take the next case. Next case, if r greater than 1. Now r greater than 1 means, can we take r equal to 2? Okay. Now find this limit. Limit n tends to infinity r raised to n means 2 raised to n. Okay, so 2 raised to n means 2 raised to 1, 2 raised to 2, 2 raised to 100, 2 raised to 1000, like this. Okay, so as n tends to infinity, this number become larger and larger. Okay, so this number approach to infinity. Okay, so for r greater than 1, limit n tends to infinity r raised to n is equal to infinity. Now take this sum Sn. So Sn is equal to a 1 minus r raised to n upon 1 minus r. Apply limit n tends to infinity on both the side. Now this value is what? When you separate the limit, then from this limit n tends to infinity r raised to n is equal to infinity. Okay, so that's why this value become infinity. Okay, so we get 1 minus infinity. 1 minus infinity is what? Minus infinity upon 1 minus 2. R is what? Suppose I assume r is greater than 1. Okay, so this difference is obviously some negative number. So minus minus cancel. What we get? Plus infinity. Okay, so limit n tends to infinity Sn for r greater than 1 is infinity. Okay, so that's why what we conclude, this series is divergent series. Next case, for r equal to -1. So in this series, put r equal to -1. So we get alternating series. Okay, first a plus here minus a plus here -1 raised to square means positive a, again negative a, like this. Okay, so here what we get? Sn is what? Sn is a minus a plus a minus a up to last term is what? -1 raised to n upon a, -1 raised to n into a. So now what is the sum? If n is even number, as we know that, suppose I am adding four numbers, 1 minus 1 plus 1 minus 1. Okay, so here total 4 numbers means even number. Then what is the answer? Answer is 0. Okay, so like this, here if a is here, what is n is even number. Okay, so what we get? Sum is 0. And if n is odd, suppose 1 minus 1 plus 1, here total 3 terms. So my n is odd, so what is the answer? Answer is plus 1. Okay, so like this, here what we get, answer is plus a if n is odd. So here now apply limit on it. Apply limit n tends to infinity on Sn. Okay, so our answer is what? Either 0 or a. So here we get more than one finite answer. Okay, so what we conclude? The series is oscillatory series, and oscillatory series means this series is again a divergent series. Next case, if r is less than minus 1. So here suppose I assume that my r is minus 2. So as we know that minus 2 is less than minus 1. Okay, now evaluate this limit. So here a 1 minus r is what? Minus 2 raised to n upon 1 minus minus 2. Okay, so now here minus 2 raised to n. Here two possibility. First, n is even. Here n is even number, then this quantity become positive. Okay, and 2 raised to infinity. Here limit n tends to infinity. So here 2 raised to infinity become very large number, infinity. So what we get? We get a 1 minus infinity upon here 1 plus 2, 3. Okay, so a minus infinity. Here 1 minus infinity. So this is the negative. Okay, so what we get? We get minus infinity. Okay, so for n is even, this limit is minus infinity. Okay, now let's check for n is odd. So when n is odd number, suppose I have 1001 number. Okay, so this negative term become negative. Say yes or no. This is minus 2. So this minus remain as it is, and it raised to infinity. So what we get? We get here minus infinity. Say yes or no. Okay, now minus minus plus. Okay, so we get what? Plus infinity. Got it? So when n is odd, what is the answer? Answer is plus infinity. Okay, so limit n tends to infinity, Sn is equal to either minus infinity or plus infinity. So that's why the series is oscillatory series, and oscillatory means this is the divergent series. Okay, so now combine all these cases. What is the conclusion for geometric series? The geometric series is convergent for mod r is less than 1. Divergent for r is greater than or equal to 1. And oscillatory for r is less than or equal to minus 1. Okay. P series. The P series 1 upon n raised to p, where p is a real constant. Okay, so what is the form of the P series? It is in a form of series 1 upon n raised to p. Okay, where p is a real constant. Now, if p is greater than 1, then the series converges. And if p is less than or equal to 1, the series diverges. Okay, so this is the P series. For example, 1 upon n square. Now compare with the P series form. Here what is P? P equal to 2. Okay, and 2 is what? 2 is greater than 1. So from these, what we can say? The given series converges. Same way, suppose the series is 1 upon n. Okay, so now compare with P series. Here what is P? P equal to 1. Okay, so now second case, if P less than or equal to 1, the series diverges. Okay, so this series is what? This series diverges. This video contain direct comparison test and limit comparison test to find the convergence and divergence of positive term series. This video contain direct comparison test and limit comparison test to find the convergence and divergence of positive term series. Direct comparison test. Use when for a given series AN, if you can easily compare it with another series BN, using an inequality such as AN less than or equal to BN or AN is greater than or equal to BN. What does it mean? Suppose one series AN is given to you, okay? Now for this series AN, you can find new series BN such that either AN is less than or equal to BN or AN is greater than or equal to BN, okay? And this new series, how to find? This new series is either P series or geometric series, okay? Then what is the condition? If 0 less than or equal to AN less than or equal to BN, means this condition is satisfied and series BN is convergent, then series AN is also convergent. If 0 less than or equal to BN less than or equal to AN and series BN is divergent, then series AN is also divergent. Means for a given series AN, if we can find new series BN, this series is either P series or geometric series, okay? तो हम इसका कन्वर्जेंट इजीली फाइंड कर सकते हैं. तो BN सीरीज का कन्वर्जेंट हमें पता है, ओके? सेकंड, इफ दिस कंडीशन इज सेटिस्फाइड, AN इज लेस देन और इक्वल टू BN एंड BN कन्वर्जेंट है, तो हम क्या कंक्लूड करेंगे? सीरीज AN भी क्या है? कन्वर्जेंट. एंड इफ BN इज लेस देन और इक्वल टू AN एंड BN इज डाइवर्जेंट, then series AN is also divergent. Okay, so here we are comparing series AN with new series BN with this type of inequality. Okay, so this test is known as direct comparison test. Okay, so now we are applying this test to our sum. Limit comparison test for positive term series. For a given series AN, find another series BN, where series BN is either a geometric series or P series. तो फर्स्ट स्टेप हमें क्या करना है कंपैरिजन टेस्ट के लिए? फर्स्ट ऑफ ऑल सीरीज AN is given to us, okay? Now we are interested to check the convergence of this given series. Now for this given series, find another series BN. लेकिन ये BN सीरीज क्या होनी चाहिए? दिस BN सीरीज इज आइदर ज्योमेट्रिक सीरीज और P सीरीज, ओके? थर्ड स्टेप क्या करना है? फाइंड लिमिट n टेंड्स टू इंफिनिटी AN अपॉन BN. दिस लिमिट वैल्यू इज L, ओके? नाउ L lie in the range 0 to infinity. Then what we conclude? Then either both series AN and series BN converges or both diverges. मतलब कि ये लिमिट की वैल्यू L अगर 0 to infinity की रेंज में है, तो हम क्या कंक्लूड करेंगे कि सीरीज AN एंड सीरीज BN बोथ कन्वर्जिस और डाइवर्जिस टुगेदर. मतलब कि अगर एक सीरीज कन्वर्जेंट है तो दूसरी भी कन्वर्जेंट होगी, और अगर एक डाइवर्जेंट है तो दूसरी भी डाइवर्जेंट होगी, ओके? नेक्स्ट स्टेप क्या करना है? फाइंड द कन्वर्जेंस ऑफ द सीरीज BN. तो BN सीरीज हमारे पास क्या है? BN सीरीज आइदर ज्योमेट्रिक सीरीज है या फिर P सीरीज, ओके? तो हम BN सीरीज का कन्वर्जेंट इजीली निकाल सकते हैं. इफ BN सीरीज कन्वर्जिस, देन सीरीज AN ऑल्सो कन्वर्जिस, एंड इफ BN डाइवर्जिस, देन AN ऑल्सो डाइवर्जिस, ओके? तो यहाँ पे हम क्या कर रहे हैं? एक सीरीज AN है जिसको हम दूसरी सीरीज BN के साथ कंपेयर कर रहे हैं, और ऑन बेस ऑफ बिहेवियर ऑफ BN series we conclude the behavior of series AN. Okay, so that's why this test is known as comparison test. कंपैरिजन टेस्ट हम जनरली कब यूज करते हैं? व्हेन इन सीरीज फॉर्म polynomial is given. Suppose the form of the series is like this: n upon n square plus 1. In numerator and denominator, polynomial is given. Okay, so in this case we can use limit comparison test. Okay.